All right, so this is question 2, part 2. We're still on the same question, only we've got two different diagrams here. Okay, so letter C, once again, our goal is to A, first find similarity, and then to find that the side ratios are equal to 1, or to find that the sides are congruent. Either way would be perfect. So we know that angle DCE is congruent to angle BCA. And how do we know that's congruent? They are vertical angles. They are across from each other, and we know vertical angles are congruent. We also know that this angle A is congruent to angle D. And how do we know angle A is congruent to angle D? Alternate interior angles, alternate sides of the transversal, but they're both inside the parallel lines. So they're both interior to those parallel lines. So we have AA. So we have similar by AA, similarity. So now we have to prove that the side length ratios are 1. And this is where I fall short of knowing that these triangles are congruent. So cannot be determined. Because I know that this is 6, but I've got no numbers over here to find side ratios. So 6 over big over small, we have no, if this is the big triangle, we don't know anything about the small triangle in order to find the side ratios. So question D. So let's start with what we know. Once again, let's start with, I'm going to do colors just to kind of help set this up. The easiest one to look at is side AB. So side AB is congruent to what side? It's going to be congruent to AB. It's congruent to itself by reflexive property. The next one I'm going to look at is side DB. And I know side DB, this one's a little bit tougher, is in between the angle with the 1 and the angle with the 2. So I've got to find the other side length that's in between the angle with 1 and the angle with 2. So that's going to be AC here. So I've got the 2 and I've got the 1. Okay, it's in between, it's the side in between those two angles. Sorry about bumping the camera. And the last thing is going to be the two remaining sides. That's going to be my blue side. Perfect. So AD is corresponding with BC. All right, so first thing we need to know is, can I prove these two triangles similar? The answer to that is yes. By what property or what theorem can I prove that they are congruent or they are similar? Right, it's going to be angle. So let's find the two angles that are congruent. So we know angle C is congruent to angle D. How do we know angle C is congruent to angle D? We know they are congruent because they are given. Okay? We've got the two lines and the two lines that show they are congruent. The next thing we know is angle EAB is congruent to angle EBA. So this angle EAB, is congruent to EBA, and we know that because they are given once again. We've got the tick marks on the paper that show us that it's given. So we've got angle similarity. The next thing we need to find is that if we have a side ratio, which is going to be 1, or do we have sides that are congruent? Because we know if they're congruent, then side ratios have to be 1. And we do. We have AB is congruent to AB. So we know the slope ratio is equal to 1. And we can give a statement saying these are congruent. So let's just start out with triangle ABC. And that is congruent to what triangle? So I did orange, blue, yellow. So you've got to match up orange, blue, yellow with the other triangle. Triangle BAD, triangle BAD. Very cool. And I've set up orange, blue, yellow, triangle bad. All right, if you have any questions, once again, let me know, but go ahead and watch the next video and go on to question 3.